Welcome to Lesson 4, Connecting to Your AI Worker. Today, we move from the physical foundation to operational control, SSH, Linux basics, and securing your server. Right now, your AI worker has a home, but we've never actually walked inside. Today, we're going to connect to that machine for the very first time. We'll explore Linux and secure this machine before we install anything else. This lesson is one of the most important in the course because every future component depends on this foundation. We are building the secure tunnel that allows you to command your AI worker from anywhere in the world. SSH stands for Secure Shell. Think of it as an encrypted tunnel between your computer and your server. Instead of sitting in front of the physical machine, you're controlling it remotely through a secure connection. Every command you type travels through that encrypted tunnel. The server executes it, and the results come back to your screen. SSH is the industry standard for administering professional Linux infrastructure. Let's walk through the connection process. We'll open our terminal, run the SSH command, and enter the server. I want to break down every part of this command so you understand exactly what you're telling the computer to do. The command is shroot at your server IP. Sh is the protocol, root is the administrative user, and the address is the numerical location of your machine. When you hit enter, you are requesting entry to your worker's home. You've just connected to your AI worker's computer. This isn't a simulation. You're now operating a real Linux machine running somewhere in a professional data center. Take a moment to realize how significant this step is. When you log in, Ubuntu gives you a status report, the kernel version, how much memory is being used, and your disk space. These are the vital signs of your server, and you now have the keys to monitor them. The terminal isn't scary. It's simply a conversation between you and the operating system. You ask a question or give a command, and the server responds. Let's learn the basic vocabulary of this conversation. WD tells you where you are. LS lists the files in that location. WOMI confirms your identity, and hostname identifies the machine. These are the simplest ways to orient yourself inside the system. To navigate effectively, you need to understand the Linux file structure. Unlike Windows or Mac OS, Linux treats everything as a file, and those files are organized into a very specific tree hierarchy. It starts at the root, or slash. Slash home is for your user data, slash exec holds your system configurations, slash var is where your logs live, and slash sr is for system-wide applications. It is a logical, predictable system designed for stability. Before we install our agent tools, we must ensure the operating system is up to date. This ensures we have the latest security patches, bug fixes, and package versions to provide a stable foundation. We run sudo apt update to refresh the list of available software, and sudo apt upgrade to actually install them. We do this before every new installation to ensure our environment is consistent and secure. Now, we need to talk about the root user. Root is the all-powerful administrator. It can do anything, including deleting the entire system. If your root account is compromised, your entire AI worker is compromised. Because root is so powerful, we never operate production systems as root during normal work. Instead, we create a specialized administrative user with limited permissions, applying the principle of least privilege. We're going to create a new user, add them to the sudo group so they can perform admin tasks when needed, and set a secure password. This simple step significantly increases the resilience of your server. By using a sudo user, you ensure that any destructive action requires a deliberate sudo command. It acts as a safety valve, preventing accidental mistakes or unauthorized changes from reaching the core system. Next, we move our SSH access to the new user. Remember, we want to stop using passwords entirely. We'll use a public key on the server and a private key on your computer to handle the handshake automatically and securely. The public key is like a lock. The private key is the unique key that fits it. You can share the public key anywhere, but your private key must stay on your machine. This is how we ensure only you can ever log in. Once the keys are in place, we disconnect and reconnect as the new user. If you see that welcome screen again, congratulations. You've successfully transitioned away from the root account and secured your entry point. Logging in without a password is not just convenient, it is significantly more secure. You have now established a professional, authenticated connection that is resistant to brute force attacks. Now we harden the system. We'll disable root login and disable password authentication entirely. But listen closely. Always verify your new user can log in before you disable root. This is a critical step to avoid being locked out. We edit the SSH configuration to shut the door on root and passwords. Once we restart the service, the only way into this machine is through your secure SSH key. You've just locked the doors to your AI worker's home. Finally, we set up the firewall. A server shouldn't expose every port to the internet. We only want to allow the specific services we need. For now, that means allowing SSH and blocking everything else. We use UFW, the uncomplicated firewall. We allow port 22 for our SSH tunnel and then enable the shield. This ensures that any random scanner on the internet can't even see the other services we might eventually run. As an architect, you need to know your server's health. I'll show you top to monitor CPU and memory in real time, and def to check your disk usage. Knowing how to read these charts is key to maintaining a production system. Top gives you a visual dashboard of every process running on your machine. You can see exactly how much power your agent is consuming. This visibility is what transforms a black box into a managed piece of infrastructure. Remember what we learned in Lesson 2. This machine continues running even after you disconnect. You can close your laptop, travel to a new city, and your AI worker will still be right here, waiting for your next command. This is the power of persistent infrastructure. Your agent is now truly autonomous because its environment is decoupled from your personal device. You've built a worker that doesn't need you to be watching it. As we finish, let's avoid the beginner mistakes. Don't work as root forever, don't ignore your updates, and please never upload your private secrets or keys to a public repository. Treat this machine with professional care. Security isn't a one-time setup. It's a mindset we build into every layer. By following these standards now, you are preventing massive headaches and system failures once your agent is live in the real world. I want you to pause now and confirm your checkpoint. If you've connected, updated, created your user, and enabled your firewall, you have completed one of the most technical milestones in this entire course. Take a moment to verify every item. If your health checks look good and your firewall is active, you are ready to move from the infrastructure layer to the intelligence layer. You've done great work today. Let's look at the stack. We have our virtual machine, and now we have secure SSH administration. Next, we install the runtime that will actually bring our AI worker to life, the Hermes runtime. We now have a secure, professional entry point. In the next lesson, we'll install Hermes, the engine that gives our worker its identity and the ability to execute complex workflows across the internet. Today, you did something many developers never learn. You established a production-ready environment for an autonomous system. This server is no longer just a VM. It is the foundation of your first AI worker. I'm Brian Jones, and I'll see you in the next lesson as we bring your AI worker to life. Let's keep building.